Okay, before we start with numbers 20 through 25, they're asking you to solve each equation. Now, in this case, you have equations, so you have an equal sign. In this case, each of these problems is going to result in some answer where x is equal to something, or your variable is equal to something. You're not just factoring and moving on. So, you have to be reminded, or you need to remember that there are several different ways you can use to solve a quadratic equation. We learned several different ways. The first thing we did was solving by taking square roots. The second thing we learned to do was the quadratic formula. The third thing we learned to do was by factoring. Then we learned how to do it by completing the square. And then we did some graphing. So yesterday well, not yesterday, yesterday in some classes, and then the day before in others, we did graphing. Okay, so with the taking of the square root, remember you're supposed to get the squared part by itself first, and then you take the square root of both sides and solve it for the variable. Don't forget, when you take the square root of both sides, you always have plus or minus. With the quadratic formula, don't mess up the formula. Remember the song, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula could be used to solve for any quadratic equation, any of them. However, I do not want you to be dependent on just the quadratic formula, because on your test, you are going to be asked to use each of the methods. So you may prefer one method, but that does not mean that that is the best method to use every time. And if you get dependent on the quadratic formula and you can only solve them that way, you're going to have problems, because, like I said, we're going to ask you to do each one of these methods on the test, because that is important for you to know in Algebra 2 and in your classes moving forward. So factoring, you remember you can factor. If your leading coefficient is a 1, check to see can you factor by just finding two numbers that multiply to give you the last term but add to give you the middle. Sometimes we have to use our box method. Some of them cannot be factored at all. You have to be able to tell which is which. On completing the square, you had a whole list of steps for completing the square. That's in that last packet that I gave you. Pull that out and look at your notes on that, but it tells you step by step what to do. So you get to choose which one you want to do on some of the problems, but some of them it's best to use one specific method, and we'll talk through it as we do those examples from 20 to 25. And then the last one is graphing. Now, the quick thing that I wanted to show you about the graphing, and I'm not going to do a specific problem, but I do want to remind you that when we graph, if we have one real root, your graph is going to sit on your x-axis something like this. This is an example of one real root. It's only going to touch, your parabola will touch your x-axis one time. Then you have two real roots. If you have two real roots, the parabola is going to intersect the x-axis twice. And whatever those two places of intersection are, those are your solutions. So this would be two real roots. And then you have the last case, something like this, where your parabola never crosses the x-axis at all. Now, if I extended the sides of this parabola, it's never going to cross the x-axis. In this case, there are no real roots, so you would end up with two imaginary roots. Okay, so don't forget, one real root, your graph is going to touch your x-axis one time. Two real roots, your graph is going to touch the x-axis twice. and two imaginary roots, your parabola will never cross your x-axis. Okay, those are quick things to remember. Okay, for number 20, this is 7m squared plus 1 equals 0. And remember I said in a little reminder a minute ago that you have to determine which one is best to use. And I know some of you really like the quadratic formula, but that is definitely not the best method to use for this particular problem. Now, this problem can be solved pretty quickly using the square root method. So what we're going to do is, with the square root method, remember you're supposed to get your squared part by itself first. So to get my squared part by itself, I have to recognize, well, what is exactly being squared? Well, the only thing that's squared in this problem is this m. Since the m is being squared, I want to try to get it all by itself first. So to do that, I'm going to follow the order of operations in reverse, meaning I'm going to undo this addition. So I will subtract this 1 from both sides. So 7m squared equals -1. Now again, I'm still trying to get that m by itself, so I need to divide both sides by the 7. So I have m squared equals -1/7. Now, since my squared part, or that m squared, is all by itself, now I'm ready to take the square root of both sides. So my next step, square root of m squared equals the square root of -1/7. Now, the square root of m squared is m. If you remember, I told you if you have a fraction underneath the radical, break it up, make it two separate pieces. So the square root of -1 divided by the square root of 7. Now, this one is going to have some extra steps in it. Because first of all, you can't leave a -1 under the radical. We do know that. You also can't leave a radical in your denominator. So you have to rationalize out that denominator. So I will multiply by the square root of 7 over the square root of 7. If I multiply straight across the top, I'm sorry, I forgot to put my plus or minus over here. Don't you forget your plus or minus. If I multiply straight across the top, I'm going to have the square root of -7 divided by the square root of 49, which we know is 7. Now I'm almost done. I cannot leave that negative underneath the radical. So the square root of a negative is always going to give you an I. So you have I times the square root of 7, and that will be all over 7. And again, don't forget your plus or minus. This is your answer. M equals plus or minus I times the square root of 7 over 7. All right, let's look at our number 21. Now again, number 21 is not in standard form. If it's not in standard form, you need to put it in standard form. So to put it in standard form, I'm going to start off by subtracting that 12n and subtracting the 4. The reason I'm doing that, because I know some of you say, well, if I just move the 6n squared, I only have to move one thing. Well, as much as possible, you always want to try to leave your leading coefficient as a positive number. So since my leading coefficient is this 6 and it's a positive, I'm not moving it. I'm going to leave it where it is, and I'll just subtract the 12n and the 4. So 6n squared minus 12n minus 4 is equal to 0. Now, there is a greatest common factor here that you can factor out. So I could factor out a 2, and then I'm thinking, well, might I be able to complete the square on this one? Yeah, I probably could. The only problem with completing the square is that it's going to give me some ugly fractions that I don't want to work with. So I'm not going to do that. In this case, I'm going to opt to use the quadratic formula. Now, you could factor out your greatest common factor and still do the quadratic formula. That's going to work just fine. I'm going to go ahead and leave it like it is, and I'll write out the formula and then substitute in. And remember, I told you, write the formula out, substitute correctly. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now, -b means the opposite of my original b. My original b is -12, so the opposite of that would be a +12, plus or minus the square root of b squared, where my b is a negative 12, and I'm going to square it, minus 4 times a, which is 6, times c, which is negative 4, all over 2a, and my a is 6. Now, 12 plus or minus the square root of 144. Now, this is where I told you everything else is going to be multiplied together. So multiply all of this. So negative 4 times 6 is a negative 24. Negative 24 times 4 is going to give you a positive 96. All over 12. So 12 plus or minus the square root of, let me see, 240. All over 12. Now that 240 can be simplified. So I start thinking, okay, well, what is the biggest perfect square that can go into 240? I'm thinking 16. Let me see. 240 divided by 16. Yep, it's 16. So I will rewrite this as 12 plus or minus. Let me do a little scratch work here so I don't confuse you. All right, the square root of 240 can be rewritten as the square root of 16 times the square root of 15. So that would be 4 square root of 15. So plus or minus 4 square root of 15 all over 12. Now break it up. Remember, break it up. So that's going to be 12 plus 4 square root of 15 over 12, or x equals 12 minus 4 square root of 15 over 12. Now remember, if you can reduce some of this, you need to. So 12 over 12 plus 4 square root of 15 over 12. Now what can go into both of those? 12, so that will be 1 plus, and then this 4 and 12 reduces. 4 goes into itself 1 time, 4 goes into 12 3 times. So 1 plus the square root of 15 over 3, or break this up again, 12 over 12 minus 4 square root of 15 over 12. Well, 12 over 12 is 1 minus, over here again, the 4 and the 12 reduce to 1/3. So you have the square root of 15 over 3. So your answers, x equals 1 plus the square root of 15 over 3, or x equals 1 minus the square root of 15 over 3. All right, number 22. Again, this problem is not in standard form, so I'm going to write it in standard form. So 4b squared minus 6b minus 54 is equal to 0. Now, this is in standard form, but I'm looking at it and I'm thinking, okay, should I use the quadratic formula here, or should I use completing the square? Well, in order to complete the square, I need my leading coefficient to be a 1. So that means I would have to divide all of my terms by 4. And if I divide this middle term by 4, it's not going to come out even. And it's going to be kind of ugly to work with for completing the square problem. So I'm not going to use completing the square here. I'm going to do the quadratic formula. So again, write the formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, now if I substitute in, negative b means the opposite of my original b. So my original b is negative 6, the opposite of that is a positive 6. Plus or minus the square root of b squared, so negative 6 squared minus 4 times a, which is 4, times c, which is a negative 54. All of this will be divided by 2 times 4. All right, so in my next step, 6 plus or minus the square root of 36 plus 880. You just need to put it in the calculator. Negative 4 times 4 times 54, and you get 880. And all of this will be divided by 8. So 6 plus or minus the square root of 916 divided by 8. Now, square root of 916 is not a perfect square, but there is a perfect square that can divide into it, and that would be a 4. So 4 times 229, and that is 2 times the square root of 229. So 6 plus or minus 2 times the square root of 229 divided by 8. Now remember I said at this point we need to start breaking things up. So I'll rewrite it as 6 over 8 plus or minus 2 square root of 229 over 8. And this can be reduced. 2 goes into 6 3 times. 2 goes into 8 4 times. Over here, the 2 and the 8 can also be reduced. 2 goes into itself once, so that leaves the square root of 229 in the numerator. 2 goes into this 8 4 times. So your answer is 3/4 plus or minus the square root of 229 over 4. All right, let's look at number 23. For number 23, you have n squared minus 3n plus 8 equals negative n. Well, again, it's not in standard form, so I need to put it in standard form. In order to do that, I have to move this n, this negative n, over to the other side. So I'm going to add n here and here. So that leaves me with n squared minus 2n plus 8 equals 0. Now that I have it in standard form and everything is in order, I look at it and I say to myself, okay, what's the best way to solve this problem? Well, the best or the easiest way to solve this problem is by factoring it. So you can factor this problem or you can do it by completing the square. I think I'm going to do both for you just because I want you to get an example of completing the square, and the other ones don't work out that way. So let's factor it first. All right, so if I'm factoring it, I'm supposed to be looking for two numbers that multiply to equal 8, but add together to equal a negative 2. Well, you know your factors are going to end up being a negative 4 and a positive 2. So to factor this, you have n minus 4 times n plus 2. Now, because there is an equal sign here, I know I'm not done. I need to take each individual factor and set it equal to 0. So n minus 4 is equal to 0, or n plus 2 equals 0. If n minus 4 is 0, add 4, and you end up with n equals 4. Or n plus 2 equals 0, subtract 2 from both sides, and you have n equals negative 2. Okay, now I want to do that same problem again by completing the square. So let me rewrite it again. Okay, again, to complete the square, your leading coefficient needs to be a 1, which it is. There's an understood 1 over here. But it still has to be in standard form before you can start. So I'm going to move this n over by adding it just like I did before. So I have n squared minus 2n plus 8 is equal to 0. Now that it's in standard form, if you look at the notes on your packet that I gave you the other day, it tells you to move the loose term to the other side. So you're moving your constant to the other side of the equation. So you're going to end up subtracting 8. So n squared minus 2n equals negative 8. Now, since I'm moving that over, hold on a minute. Okay, class, you know what I just realized? First of all, I realized that it's almost 5 o'clock and I'm still here and I'm tired, and I just realized that I did number 23 wrong when I did it over on this screen. You can't factor this. I don't even know what I was thinking, but I guess just I'm tired again. So when I gave you these factors, the negative 4 and the positive 2, if you multiply them, you get a negative 8, and I neglected to realize that that's plus 8. So please disregard all of this whole problem that I did over here. Please disregard it. Come back over here with me to this problem, number 23. This one has to be done by completing the square or by the quadratic formula. Again, I truly apologize. That just lets me know I really need to go home because I'm tired and I'm making careless mistakes. So I apologize again if you copied that one, number 23, the first time. But let's go ahead and do it by completing the square. So we said that you had to move your loose number over to the other side. So I subtracted 8 from both sides. So now I have n squared minus 2n equals negative 8. At this point, I'm ready to complete the square. So to do that, you're going to take half of your middle term. So take half of this coefficient, which will be a negative 1, and then you're going to square it. Now, when you square it, you're going to get positive 1. That positive 1 must be added to both sides of your equation. Now, once you add the positive 1 to both sides, you've created what's called a perfect square trinomial on the left side of your equation. That perfect square trinomial will factor to be n minus 1 squared, and that's going to equal negative 7. Now that my squared part is by itself, I can take the square root of both sides of the equation. So the square root of n minus 1 squared equals the square root of negative 7. So I end up with n minus 1 equals plus or minus the square root of 7 and then your I. Now remember, I told you before, you can put the I in front of the radical or behind it, but that I is not to be underneath the radical. So I'm almost finished. I need to add 1 to both sides. So n is equal to 1 plus or minus the square root of 7, and then you have your I back here. If you prefer to put your I in the front, you'd have n equals 1 plus or minus I times the square root of 7. So again, you may see the answer either way, but they're both correct. Okay, these are the last two that I'm going to do for now because, like I said, I'm really tired and I'm just making careless mistakes. But for number 24, this problem has 2 times x minus 2 squared equals 32. So the first thing I need you to remember is that in this case, it's not going to be acceptable for you to distribute that 2 times the x minus 2 squared. According to the order of operations, you would have to take care of exponents first before you could do your multiplication. So you're not going to multiply this 2. What I will suggest is getting the squared part by itself, and to do that, we're going to divide both sides of this equation by 2. So if I divide this side by 2 and this side by 2, the 2's will cancel out over here, and I have x minus 2 squared is equal to 16. Now, since I have x minus 2 squared equals 16, my squared part is by itself, so I'm going to take the square root of both sides of the equation now. The square root of x minus 2 squared will simply be x minus 2 equals plus or minus 4. Now, add 2 to both sides of the equation because you want your x by itself. So x equals 2 plus or minus 4. Now that's going to give me two separate answers. So the first one will be x equals 2 plus 4, or x equals 2 minus 4. For the 2 plus 4, you have x equals 6, or x equals negative 2. All right, last one. For number 25, again, I'm looking at this problem and I'm thinking to myself, what's the best way to solve it? Well, always look for greatest common factor first, and in this case, my greatest common factor is an 8x. So I'm going to factor out 8x. And remember, if I'm factoring out an 8x, that basically means I'm dividing everything by 8x. So the first term divided by 8x will leave me x, minus the second term divided by 8x. The x's will cancel out, but 32 divided by 8 is 4. And 0 divided by 8x is still 0. Now I've got 8x times x minus 4 equals 0. Now at this point, I'm ready to set each of these factors equal to 0. If it has a variable in it, you must set it equal to 0. So 8x is equal to 0, or x minus 4 is equal to 0. So over here, you divide both sides by 8. X equals 0, or add 4, and x equals 4. So your answers are x equals 4 or x equals 0. Okay, guys, anything that I have not finished doing on this review, we will do in class on Monday. Miss TS is exhausted. It's 4:48 on Friday afternoon, and I'm getting ready to pack up my things and go home. Again, we'll finish up number 26 through whatever that last problem is when we get back. But I still want you to do them on your own. Also, don't forget you have the Unit 1 practice test online. Go to my eClass page, click on Classroom Assessments, and try to get that done. The deadline to do it is 11:59 on Sunday night. You guys have a great weekend, and again, I apologize for my mistakes, but please forgive me and know that school has been out for almost 3 hours and I'm still working. So, y'all be good. See you Monday.